No, I don't really close my eyes. This hill, by the way, is a 32% grade. You better understand angles. That's an 18-degree angle, 5 times as steep as any driven highway in the Rockies. Icefield explorers are equipped with a special feature called transmission lockup, which means I more or less have to drive the machine down the hill. Very little braking. Just a little bit about the machines as we get started. There are 23 in total. We have 22 right here in Alberta, built by Canadian Foremost in the Calgary area, a company big in the manufacture of oil field equipment. 23rd Icefield Explorer, by the way, would be on Antarctica, used by an American base for service purposes. The tires, Michelin, 5 feet high, 3.5 feet wide. They serve 3 purposes, of course. 6-wheel drive traction, 15 pounds pressure, very spongy to help with the rough terrain. But most important of all, they don't damage the glacier as did the old track machines. Now this area is called the ice core moraine. If you were to dig down 12-15 inches in those piles of rocks and gravel, underneath you would find the Athabasca Glacier. Ice core moraine. And that thin veneer of rocks and gravel on the glacier has prevented the glacial ice underneath from melting as fast as the main body, which is exposed to the wind, sun, and rain. Where did it all come from? Well, those mountains to the left there, very soft rock. The water's constantly trickling in through the cracks and the crevices in the mountainside. And as the glaciers were moving down the valley over hundreds of years, it all tumbled down and the glacier was carried down the valley. Now as we're coming down the hill, we're picking up a lot of mud in those big tires, so we put a dam on this small stream. The idea is to wash the tires before we go on the glacier. Mud on the glacier is not a good thing. Call this one, of course, the Athabasca Tire Wash. Yeah. You see those ice crystals on the surface of the road? They're made by a special blade. And those big tires can grip the crystals. Without the crystals, of course, the tires will spin. Coming up on the actual surface of the Athabasca Glacier, which, by the way, is 1 kilometer wide by 5 kilometers long. And the glacial ice you can see from the toe to the very first step of that head wall represents only 4% of the total size of this huge ice field. And as we look off in the distance, we can see the first 2 steps, and right on the horizon, a huge snow ridge. Well, that's the beginning of the Columbia ice field. We're like a child at a dinner table, we just can't quite see over. Yeah. This huge ice field is 325 square kilometers, about roughly 130 square miles of solid ice and snow. So what we have is a huge plateau at a very high elevation, the Columbia ice field. Now the ice field itself is surrounded by 11 of 22 of the highest mountains in the Rockies, creating a natural barrier. Well, river valleys that go all the way to the Pacific Ocean. So what we have is warm, moist air constantly flowing in from the Pacific, guided by those river valleys up on the plateau, and precipitation forced to fall in the form of snow. And snow it too, 8, 9, 10 meters, 30 feet. That's not uncommon as a annual snowfall on the Columbia ice field. And it do snow in July up there, and it do snow in August, yeah. And as those huge accumulations of snowfall continue, year after year, tremendous pressure is exerted on the layers underneath. The air bubbles in the snow are squeezed out. It begins to crystallize, and we have the formation of glacial ice. So all glacial ice worldwide, not only here, is actually formed by snowing and pressure, not by water and freezing, as is ordinary pond ice and sea ice. As those huge accumulations of glacial ice buildup continue on the Columbia ice field, then a phenomenal thing happens. The glacial ice begins to move like cold molasses or liquid plastic, overflowing out through 6 major outlet valley glaciers, of which the Athabasca is one. So what we have, the glacial ice is overflowing, moving gradually, slowly towards the valley floor. But in the summertime, the glacial ice melt back is much greater than the overall advance. So we actually have a net loss each year off the toe of the glacier of about 10 meters, 30 feet. Some say it's global warming, more say it's a natural cycle. Maybe a combination of both. In any case, for the most part, all the glaciers in this area have been in retreat since the 1800s. Now we look to our left high in the mountains, we can see a glacier. That glacier don't have a name, but the locals call it the AA Glacier because on the left we have Mount Athabasca, on the right Mount Andromeda. It's not part of the Columbia ice field, even though it was formed in the same manner. It did carve that huge valley out between the two mountains over many, many years, and at one time was flowing directly into and onto the Athabasca. But the Athabasca's melted away, left it hanging, and they call those types of glaciers independent hanging valley glaciers. Okay, let's swing over to our right-hand side, and we have Mount Snowdome. It's called Snowdome because there's a huge dome glacier sitting directly on top of that mountain. Part of it is visible like icing on a chocolate cake farther up the valley. Snow Dome is interesting in another aspect, in that it's a true triple continental divide. The only one in the world in existence. And to explain, let's today trace the meltwaters of Snow Dome going to the north, going to the west, I should say. It will flow into the Bush River, the Columbia River, 2,000 kilometers, 13 hydro dams entering Pacific Ocean near Portland, Oregon. Meltwaters from this area will find its way into the Sunwapta River to the north, the Athabasca, 2,000 kilometers. Finally, the mighty Mackenzie all the way to the Arctic Ocean. Meltwaters going to the east will find its way into the North Saskatchewan River, and slowly but surely all the way into the Atlantic Ocean in Hudson Bay. So many of the great rivers, northwestern United States, western Canada, begin right there, going Pacific, Arctic, as well as the Atlantic Ocean. Now, if we come back over to the left-hand side, we can see Mount Andromeda. This would be the Andromeda Glacier. It's called a cirque glacier from the Latin word circle. If you look behind the glacier, incredibly, the glacier has eroded away the whole side of the mountain over thousands of years. And now as you tour throughout the Rockies, you'll see many cirques in mountains. In most cases, well, the glaciers are long gone. But in this case, we've sort of caught the Andromeda Glacier in its final stages of eroding away the whole side of that mountain. From this vantage point, we can clearly see the 3 steps of the Athabasca head wall. The glacial ice in this area is forced to flow over 3 cliffs of rock up there. In doing so, it has to travel faster at the surface, it's more brittle. Huge crevasses open up. If we look closely in some areas, you can see large standing towers of ice. They're called seracs. As the glacial ice flows down on a level, for the most part, they all close up. Now the turnaround, as well as the road, has been graded this morning by heavy machinery for safety reasons. Inside the blue cones is a safe area. Outside is no man's land, can be dangerous out there. So we'll have until 12:35, plenty of time to experience the glacier. You don't have to leave the Icefield Explorer if you don't want to, of course. and the door is going to be open to return at any time. This general area, scientists tell us, is over 300 meters, 1,000 feet of glacial ice to the bedrock.